Well, hello everybody. What we're looking at here is another problem from MyMathLab. I just took a screenshot and I've got the answers already prepared, but I want to show you how we get them, okay? Uh, as I say for some of the videos I do, I might say you'll see a problem like this on the assignment with different numbers. It might be hard to figure this problem out if you've never seen anything like it, if nobody's ever showed you, but I'm showing you and I'm just asking you to take what you see in the video and reapply it to the problem that you find on MyMathLab. Okay, here's the problem. It says that we have a rectangular tank with a square base. Just to help you imagine what we're dealing with, I sketched that out right here. They call it a tank, but you could think of it as a box if you wanted to. It's got a square base, and what that means, well, what's a square? It's this two-dimensional figure where each side is the same length. So on this square base, I'd say, well, that side is x, and this side is also x. I don't know what it is, like it's not given in the problem, but I need to call it something, so I'll call it x, okay? Now there's like another edge over there, that's also x, and there's one in the back, and that's also x, okay? All right, so it's got a square base and open top, so I could think of it like there's no lid on this box. So I did a little shading there as if to say like, well, there's nothing up there. There's four sides to this tank or box, and then there's a base. That's what it is. Next, it tells me the volume is 19,652 cubic feet. Cubic feet is a measure of volume. There's lots of ways you can measure volume. Gallons is a measure of volume. Okay, you have a gallon of milk. They're telling you how much milk you have. That's volume. Here, though, it's cubic feet. Typically, our units of measurement are compatible. So if you're telling me that the volume of this box or tank is 19,652 cubic feet, that means all the linear measurements of the base and the height are also in feet. Okay, so it's x feet by x feet on the base. One more thing I did is I measured how tall it was. I mean, I'm going to need to incorporate that number in order to solve this problem. Not only do I need something for the lengths of each side of the base, but I need to know how tall it is. I need to say something about it. It wasn't told to me how tall this box is, so I'll just call the height h. H is how tall it is. That's the length of this edge or this edge or this edge. They're all h. Okay, so I did my labeling. I put x and h because I don't know what those numbers are. They weren't given to me. And that's what we do when we don't have something. Okay, all right. Now, question is this: find the dimensions of the tank that will minimize the surface area. So you might think of it as, if the volume is fixed, if the volume needs to be that, 19,652 cubic feet, how could you construct it so you use the least material? Okay, it's like saying that. The surface area is the total area of the four sides and the base. Okay, think each part of this has an area to it. See this rectangle on the front? That has an area to it. That has a size. It's x times h. And do you see this rectangle on the sides? Same thing. It has an area. It has a size. That's also x by h, the area of a rectangle. So in order for me to find the dimensions, and by dimensions it means like how big should the base be and how tall should it be, in order for me to minimize that, I need some function that measures or tells me the surface area of the tank. Okay, so all right, let's think of it like this. The surface area of the tank is this. The tank is made from four sides and a base. So if I can tell you the area of the four sides plus the base, then that would be a function that tells you the total surface area of the tank. Okay. Now, I mentioned a minute ago that, well, the area of this rectangle that makes the front of the tank is x times h. And the area of this rectangle that makes up the left-hand side of the tank is x times h. But they're all like that. they're all four sides of this tank or box are having an area of x times h. There's four of them. So 4 times x times h is the total area of the four sides. What about the base? There's a bottom for this box or tank. Well, it's a square, and the area of that is x times x, or x squared. Okay, so there I have a function here that tells me the surface area of the tank. That's good because that's what I want to minimize, all right? Now, the problem with this is that it has two variables, x and h. Okay, it has two unknowns. And we don't really deal with functions like that unless we take advanced calculus, all right? So, can we eliminate h is my next question. And you might think, well, we didn't incorporate this bit of information that the volume of this box has to be 19,652 cubic feet. So I can use that to eliminate this h out of there, and I'll have to. Now, again, I know I said this already, but I'm aware that doing it this way is not something most people would think of all by themselves, but I'm showing you, okay? So the next step is this. Incorporate the volume, okay? I was told the volume was that. What is the volume of this shape? Well, I'll tell you. It's x times h. It's this side times that side. That's the volume of a box, okay? So if the volume is supposed to be 19,652, and if the volume of a box in general, like this one, is x squared times h, then x squared times h must be 19,652. And if I wanted to sub the h out of this and get rid of it, so I don't have two variables, I'll solve for the h, okay? Right there, I'll divide both sides by x squared, and I'll say h is 19,652 over x squared. So sub that up here right at that spot, and then h is gone and we get a function of one variable. That's what we need, okay? So if you do that, okay, then you'll get this 4xh plus x squared. If you cancel the x's and multiply 4 times that number, you get 78,608 over x plus x squared, okay? Now that's the function that we want to find the minimum of. We want to find the minimum surface area. And how do we do that? If this tells me the surface area of the box, and I want to know the minimum surface area that's possible, because there are lots of ways you can construct this box. You can make it taller, you can make it shorter but wider. There's lots of ways it can be done. There's only one way that has a minimum surface area to all the material used to make it. Okay, so all right, I can do that by finding the derivative of this and setting it equal to 0. All right, now one more thing, back to this question. If I look at this question in parts, it says write the objective function. Now the objective function is another name of the function that we want to minimize or maximize, whatever the case is. So here's the objective function. One more thing you'll notice is that it said let s be the length of one of the sides, and I don't like using the variable s when I write my work, because when I write an s it looks like a 5, so I used x, okay? But notice, like this thing I got right here, a is 78,608 over x plus x squared. That's the same thing as this, just with x instead of s, okay? All right, that's the objective function. That's the function we're trying to minimize. All right, what about the interval? Well, what they're asking about there is, what are the possibilities for the variable in this function? Okay, so we'll think about like this. So what is the, here's my function that measures the surface area. What is the x doing? Like, what's the purpose of that? It tells you the side length of the base. It's x feet here and x feet that way. So for this right there, for that function, x equals 0, like that's no good, right? You can't really have a box if the base is 0 feet by 0 feet, so that's out. but also because it's a measurement of length, x being a negative number is also out of the question, because it wouldn't really be sensible to say that the length of the base was -2 feet or negative anything feet. Okay, so for this part right here, the interval of interest are just the possibilities for the variable, whatever the variable is. And that would be, well, if 0 is out and if negatives are out, that would be the interval 0 to infinity. Remember, when we write an interval, if we put a parentheses, that means we're not including this boundary number. So this right here leaves out the 0. Remember, we wanted to leave out the 0. If I had written it with a bracket, I would be including the 0. Okay, but that's not what we want here. Remember, in that function, s or x, whatever you want to call it, the length of each side of the base is going to not be 0 and not be a negative number. Okay, so here we have our objective function. We have our function we want to minimize in this case. We'll find the derivative and solve it for 0 to do that. Okay, so what I did from here to here is I rewrote the objective function, but I put that x up there with an exponent of -1. That's typically what we would do to use the rules for finding derivatives. Then I found the derivative with the rule. Okay, we get to there, and I didn't want to focus too much on that because that's something we've seen in other lessons. If you were unclear on how I found the derivative or how I used the rules, you could always ask about it. Okay, all right. From there, I need to take that, which is the derivative, and solve it for 0. So I wrote that down here. I moved this term over there. It became positive. I cross multiplied this x squared over here. It became 2x to the third. I divided by 2 and I got this number. And now to solve for x, if I have x to the third power is 39,304, how do you think you solve for the third power? You apply the third root to the number on the other side. So I got to do third root of 39,304. With my calculator, I got 34. So that's x. That tells me the base should be 34 feet by 34 feet. So, all right, that's the most optimum way to make this with minimum surface area that uses the least amount of material, but still has the volume that we need, okay, is going to be 34 feet by 34 feet on the base. So that's why it says the square base with side length 34 feet. Okay. All right. Next thing, I need to find the height. Okay. This shape had as part of its features a length of each side of the square base and a height, h. H tells me its height. H tells me how tall it is. So I need to find that number too, okay, in order to give the dimensions of it, meaning all aspects of measurement, okay? So how do you think that we could take x, which we found and we now know is 34, and find h? Well, maybe we could look in our work. Do you see h anywhere? Do you see an equation that seems to tell you what h is? This one does. You know, I could look at all of them, and this is the one that jumps out at me. It says h is 19,652 divided by whatever the x is squared. And we just found the x, so we could use that, okay? So sure, I'll find the height of that box as 19,652 over x squared. I just found x to be 34. With my calculator, I did that divided by 34 squared. I got 17. So that's why up here it says the height needs to be 17 feet. Okay. If you deviated from this, if you made it any taller or shorter or any wider or narrower, you would be using more material. The surface area would be bigger. Okay. But making it this way gives us the volume that we need using the least amount of material. That was the objective of the problem. All right, now you take away from this whatever you need. When you solve it, you don't have to draw the picture. I just did that for you. It makes the instruction a little bit easier. You could almost just go through these same steps, okay, with whatever varied and different numbers that you have for the same problem. Okay, so I hope that's enough to get you through it. that you can watch this video and attempt a similar problem from the homework on your own. And if that's not enough, if you're still having trouble, let me know.